This is lesson 4.6 on misleading graphs and statistics. This is something for math that you actually see a lot of in the real world. Pay attention to the news channels, to billboards, to articles online. There is a lot of information being presented to you. And often many graphs and statistics are being presented to you in order to persuade you one way or another. You got to keep in mind that somebody has made this graph, and most people have a motive. So advertisers may present information in a certain way to make their company look good, or politicians may present something in a certain way to drive laws a certain way, etc. So just keep in mind that everything you see, somebody has created it. You really want to analyze graphs and statistics and pay attention to who is presenting this information to you to make sure that you're interpreting it the right way and seeing if there's a motive. So here's a couple examples, but I love this lesson because this is something that you really can look for in the real world. You can look it up online, and there's lots of real examples of past companies presenting information and then kind of getting busted on the fact that they presented it misleading on purpose. So let's take a look at example 1. Here's a couple examples here. It says, explain why the graph is misleading. And also I want you to explain what might it cause you to believe, because I think that part helps you to understand what is misleading about the graph. So let's take a look at this first graph. It's kind of a bar graph. There's pictures of newspapers. Let's read the headings. Newspaper sales in print and online for the Times newspaper and the Daily Telegraph newspaper, okay? We're going to assume they didn't lie about the numbers. We're going to assume it looks to me like the Times sales are about 485,000 and the Daily Telegraph sales are about 450,000. We're going to assume that they didn't just make up those numbers. That's not the part that's misleading. What about this graph is wrong or incorrect? Well, one thing I notice is whenever you are looking at the y-axis here, notice the y-axis starts at 420. And then they're counting by 10,000s because it said in thousands, so that's fine. You can count by 10,000s, but the problem really lies in the fact that they did not start at 0. The other thing that I want you to notice is that if these were bars, notice this bar, since it's a picture, is actually a lot wider than this bar because it's a smaller picture. And that little bit will actually be misleading as well. So what is misleading about this graph? Well, the y-axis doesn't start at 0, and the graph uses pictures as bars. And why is that a problem? Both of these things really exaggerate the differences between the two companies. So I want you to write that down, and I typed it. You can pause the video to get these notes written. I kind of typed a lot because I wanted to be very thorough. So here's the thing. At a glance, if I were to just look at this graph without really reading the numbers, because they chose clip art as the bars, I may believe that Times has 4 times the sales as the Daily Telegraph. Where am I getting that 4 times? Kind of look at it this way. This bar is really skinny, so I could actually put 4 of them over here in this picture, and it looks like the Daily Telegraph is about 1/4 the size of the Times. Does that make sense? I like doing a number comparison like that because that really is what is exaggerated. Because the y-axis starts at 420, that also plays into this. If they had just used regular skinny bars, it would maybe look like it was half the size, which is still a lie because the graph doesn't start at 0. So there are 2 things misleading about this first graph. Again, pause the video if you need to write this down. The y-axis doesn't start at 0 and the graph uses pictures. Both of these really exaggerate the differences between the companies. Awesome. Let's look at the next one. Okay, we've got a line graph here. It says profits of our company. I don't really know what company it is. Months, October, November, December, January, February, March. Always check these scales. Did they count by something consistent? In this graph, they didn't do anything wrong per se. What they did is they used a break. That little squiggle is a break in the graph. So they went from 0 to 14,000, but that break allows you to skip numbers. Okay, so a break is not illegal, it's allowed. However, it is or can be misleading. Because the graph starts at really like a break and then 14,000, what does that do? Well, the break also kind of exaggerates the pieces of the lines. It exaggerates the change in profit here. So what is true about this company? The profit is increasing. That is not a lie. But why is this misleading? Well, the break makes it look like the company is really experiencing a large increase where, you know, $1,400 extra, it's an increase, but it's not maybe massive. Also, we don't know what this company is. Maybe this company is, you know, they sell a lot of stuff for springtime, or they're something like pool supplies or something. So, you know, maybe not a lot of people are buying that in October, November, December, January, but, you know, February to March, people are starting to think about that. So it'd be helpful to know what company it is. Anytime you're looking at graphs and trying to figure out what's misleading, check that there's headings, check that there's labels, check the scales. And again, it's not necessarily that they're lying to you. It's just that the way they presented the information is presented in a way to help you see the information a certain way. In both of these cases, I would say it exaggerates the differences between the bars or the lines. Some other common ways that graphs can be misleading: if the vertical scale is kind of too big or too small, if it skips numbers, maybe it's counting by fives and then all of a sudden it counts by 100. It doesn't start at 0, whether that means it starts at 420 like our first one, or even if they use a break. And again, a break is allowed, but it does cause the graph to be misleading. The graph also might be missing labels. The bars or pictures could be different sizes, especially we'll see this if they use a 3D bar. If they use a 3D bar for a bar graph, that also, as it gets taller, it gets wider, it makes it look bigger. And then also another way that graphs could be misleading is if data is left out. Okay, let's look at example 2. 3 friends go bowling, and then Jack and Mia graph their scores. So there's 3 people bowling. Leo does not graph his scores. I'm telling you that Jack and Mia have created these graphs. I want you to identify what is misleading about each graph, and also I want you to take a guess. Could you guess who would have a motive to make each graph? This would be a great point to pause the video and try this one on your own, and then press play to go over it. Okay, so hopefully you've tried it on your own. Hopefully you noticed the 2 misleading things, because we kind of have talked about them already. This first graph, graph number 1, does not start at 0. That's a problem. Graph number 2, I mentioned it up here, the vertical scale is too big. This is going all the way up to 500 when there's no need to. The data is all the way down around 100. They maybe could have gone up to 200, but they went well beyond what they needed to. All right, so what does this cause? See, graph number 1 is misleading because the y-axis doesn't start at 0. And graph number 2 is misleading because the y-axis scale goes way beyond the data values, all the way up to 500, and it's really only needed to be a little over 100. How could we guess who would have a motive to create each graph? Okay, well, when I look at the graphs, I can clearly see that Jack won. Jack had a score of about 125. Leo had a score of 119. Mia had a score of 114. My guess would be that Jack would make, if he won regardless. Which graph would he want to show, 1 or 2? Well, which graph makes Jack look better, right? 1. Jack probably created graph number 1 because then it looks like he won by a lot over Leo and Mia. He did win. He's not lying. He's just making his win look bigger or more obvious. So if Mia created the other graph, because I said I left Leo out, he didn't create one of these graphs, Mia would have motive to use graph number 2. Why? Well, she lost, but in graph number 2, it's not as obvious, right? She looks like she was neck and neck with Leo and Jack. So Mia would probably create graph number 2, so she looks close. All right, so we talked about how graphs could be misleading. There's lots of ways this could happen. I gave you a few examples. Let's talk about statistics. Statistics, guys, pay attention. You'll hear statistics on the radio, on TV, on billboards, you will see them. Statistics give a percent, or statistics can be misleading. And some of the ways they do that is they could give a percent, and it's really from a very small sample size. You know, when I read a statistic on a billboard and it says 80% of dentists recommend this toothpaste, I think, do I know how many people they polled? Did they ask 100 people and 80 of them said this is the one that's better? Or did they ask 5 people and 4 of them said this one was better? I also think, where did they ask the question? You know, the way the statistic is gathered could be misleading. So whenever you're reading a statistic, it's a good statistic if you know where the statistic happened, if you know how they worded the question. Did they kind of lead the question, or did they really ask the question very general? Who did they choose to do the statistic? Because that could also cause your statistic to be misleading. Even if you have a voluntary survey, I get those receipts all the time at the grocery store or at a restaurant, and it says, you know, go online and complete the survey for your chance to win a gift card. Well, you know, if it's voluntary, that could produce misleading results. To be honest, I'm probably not going to complete a voluntary survey unless I am A, really, really happy and blown away by my service, or B, really upset and disappointed, and I want to make sure I tell somebody how terrible it was. So for me, if I'm just in the middle, I'm probably not going to complete a survey voluntarily. And then the other way that a statistic could be misleading would be if the data is, the way a data is grouped can kind of change the statistic. And that's harder to demonstrate, but it's something that as you get older, you might see more examples of. But the way they break up people into categories could also be misleading in a statistic. Okay, so let's do 3 examples. These would be kind of statistics I think you would hear, especially in middle school. Explain why the statistic is misleading. A survey given to YMCA members claims that 90% of people work out at least 3 days per week. Why is this misleading? Well, if you guys are familiar with what YMCA is a gym. And what is the survey about? Working out. If they give the survey to people who are already YMCA members, how could that be misleading? Well, they've given this statistic is misleading because the survey was given at a gym. People at the gym already are there to work out, right? If you already are a member of the YMCA, you probably value being healthy and working out. Results might look different if the survey was given at a more, neutral place, like at a library or a grocery store. You'd have more varied people there. Okay, good. Let's look at the second one. A football fundraiser is selling Panther discount cards, which gets you discounts at 25 local businesses. In their advertising, they claim these cards can save you up to $200 in a year. So what's misleading about this statistic? Again, misleading graphs and statistics, they're not lying, they're just misleading. What keywords do I hear here? Up to. See, people will hear that $200 and they think, oh, I'm going to save $200, but the keywords are up to. This statistic uses the words up to. You might only save $1 or $5 from this fundraising card. See, up to does not guarantee that you're going to save the full amount. I hear commercials all the time about Aldi and their savings. So up to is, again, they're not lying, but it's kind of a little tricky because you hear that number 200 and you think you're going to save close to that. Actually, most people might only save a few dollars, and maybe there's just a few outliers that save 200. That actually leads me to my next example. Juicy Fruit advertises that their flavor lasts for an average of 55 minutes based on the following durations reported by customers: 12 minutes, 33 minutes, 5 minutes, 200 minutes, and 25 minutes. Okay, so I think there are really 2 things misleading here. First of all, if you didn't know that this was the data, you're thinking the average of 55 minutes, I would think they polled a lot of people, when really the data is only involving 5 customers. Is 5 a very large sample size? No. The other thing that catches my eye is the word average. Now, average, what is the true mathematical average? It's the mean, right? Why is the mean not a good representation here? Do you notice that there's one data value that's kind of very different from the other ones? Yeah, this data set definitely has an outlier. So I think that this isn't a good statistic because the sample size is very small, but kind of more importantly, this statistic uses the mean as the average, and really the median would have been a better representation. Because there's an outlier, the 200, the mean is kind of skewed. It's pulled up. In fact, how many people were able to chew their gum and have the flavor last for 55 minutes. Only one of them. Most of them were significantly less than that. Again, these are just a few examples of way graphs and statistics can be misleading. I encourage you to kind of keep going with your research on this and look it up and look for examples in the real world, because this is something that you will see in advertisements, on TV, etc. Hope this helps.